Hello and welcome to another one of Dee's ADD videos. Today we're going to be looking further at the concept of domains by trying some slightly more challenging problems and determining their domain. So take a look at this function here. We have a rational function. Right off the bat you should see this denominator and know to set that not equal to 0 and solve. So denominator cannot equal 0 we start by factoring out the x, and when we're left with the x squared minus 9 we see that can factor further into a difference of 2 squares. Try not to bring this over to the right side and divide the x. You will lose one of your domain points. Okay, so now that we have these, all we have to do is really either give your answer interval notation, or if you can't visualize quite what it is, draw yourself a number line. The law of 0 says that each of these, when multiplied not equal to 0, can also have them individually not equal to 0. And when we evaluate, you get open dots at -3, 0, and 3, but everywhere else it's defined. So the way that would look like in interval notation is as follows. We would have -infinity to -3 for this portion, -3 to 0 for this portion, union 0 to 3, union 3 to infinity, everybody gets parentheses. Again, never brackets with infinite values, and because these have open dots, we can't include them. If we included them, the denominator would be 0, you get a number over 0, and it'd be undefined. All right, on this problem here, we've got a square root and 9 minus x squared underneath the radical. So as you know by now, you should know, you cannot take the square root of a negative number. That results in imaginary answers, complex number systems, stuff like that, that is going to be outside our domain discussion that we're dealing with. So what we do now is we do the same basic rule. We set whatever's under the square root greater than or equal to 0. Now right away you should notice that the power of x is no longer 1. It's greater than 1, and because it's greater than 1 and we have an inequality, a greater than or equal to in this case, we have to do sign analysis to solve this inequality. And in sign analysis, what you want to do is you want to go off to the side and you want to find your cut points by solving where this equals 0. So just do a little algebra, set it equal to 0, factor, and then you get x equals plus or minus 3 as your cut points. Then what you want to do is you want to draw those on a number line, and because we have an equal sign there, we get closed dots on both of these. Now we look for test points on either side of the cut points and plug them in. You don't care about what the exact value is, you only care about the sign. Is it less than 0 or is it greater than 0? So it's easier to use your factored form whenever you're dealing with this. So to plug in a 3 minus 5, or 3 plus a -5 is a negative number, 3 minus a -5 is positive, so that's a negative times a positive is going to be a negative. And plug in a 0, those are two positives. Plug in a 5, you'll get a negative and a positive again. And when you finish all that up and plug and chug your values, you should get less than 0, greater than 0, less than 0. We only care about the greater than 0 regions for domain, so that would be your final answer, -3 to 3. Notice we are using brackets because of the equal sign found here in the closed dots. All right? So the final problem we're going to do on this intermediate video is 8x over x squared plus 9. And at first glance, you might say, hey, this is one of the regular ones I've been doing, and I have a denominator, and I would set it not equal to 0 and solve. But if you take a step back and look at the forest instead of focusing on just one tree, you would see the big picture here. And you would see that whenever you have an even exponent, this is always going to be positive, no matter what I plug in for x. And then I'm going to add a number to it. So that will make it more positive, therefore never equaling 0. If we never equal 0 in the denominator, then we don't have a restriction, and your answer should be all real numbers or -infinity to infinity. Had you worked it out and tried to solve it, you'd get the square root of a negative number, and that would clue you in as this being a special case scenario, and then hopefully you'd realize what was going on. All right? So practice, practice, practice as always. There's still the advanced videos to watch. As always, there's still the advanced video to watch for domain. We're going to have a little bit more sign analysis and some other things that I want you to make sure you are familiar with. Hope I helped. Thanks for watching. Have a great day.